All right, on to homework number 5, unit analysis. So let's get started. This is question number 2 off homework number 5. Question number 1, I'll let you try to figure that out yourself. Go ahead and email me if you have any questions and I can send you a video. So starting off, Larry ran 23 miles per hour for 22 seconds. How many yards did Larry run? So in a testing scenario, I will provide all of the equations that govern the situation and all of the relationships between yards and feet, um, miles and feet, all that good stuff. So I guess for the time being, you'll have to just go off my videos for this. So Larry ran 23 miles per hour for 22 seconds. How many yards did Larry run? So how many yards, what we're solving for here is a measure of distance, or distance equals, let's see, speed. So speed is miles per hour, so that would be distance over time. So distance equals speed times some amount of time. So if we take a speed and we multiply it by some amount of time, what we get in return is a distance. So this is the equation that governs the situation, and let's go ahead and fill in what we know. So Larry ran 23 miles per hour. That's going to be our speed. So this is going to be 23 miles per 1 hour. Now recognize speed is a fraction. If you do not have speed set up as a fraction, you won't have much to work with. So when I say speed is a fraction, I'm saying you need to put 23 miles in the numerator and 1 hour in the denominator. That word per, that magic word per, really is a red flag for a fraction. That word per is a verbalization of this horizontal line. So this really does read 23 miles per 1 hour. The amount of time we're working with here, well, that's the 22 seconds. So 22 seconds. Now let's clean this up a little bit. So we have distance equals 23 miles per 1 hour being multiplied by 22 seconds. Now, believe it or not, this actually is a distance. It just doesn't mean very much to us. So, and keep in mind the distance we want out, how many yards did Larry run? So I'm going to write myself a reminder that I want distance in yards. So, the process from here is to inspect your units and recognize which ones need to go away and which ones you want to stay. So we need yards out. We're solving for distance in yards. So nowhere over here do I see yards. So all of these units are going to end up going away. And the big question is, well, how do you get the units to go away? And we get the units to go away by multiplying by clever versions of 1. So the approach to this is, well, recognize miles is upstairs. I'll go ahead and write that out explicitly, miles. So we have miles upstairs. I want miles to go away because I want yards. I don't want miles. So miles needs to go away. The only way to get miles to go away is if I multiply by a fraction where miles is in the denominator. Now this multiplication by this fraction is only valid if this fraction is equal to 1. Multiplying by 1 leaves your equation unchanged. So, I mean, it really would be convenient if I could establish a relationship between miles and yards. However, I don't know that off the top of my head, but I know how many miles, or rather, I know how many feet are in a mile. So I can relate miles to feet. So again, miles was upstairs, so I introduced miles downstairs. So this unit will undo that unit. However, I can only do this multiplication by this fraction if this fraction is equal to 1. So I need to relate miles to something familiar. So I know 1 mile is 5,280 feet. Now keep in mind I don't want feet out of my equation. What I do want is yards. So I'll do a similar approach, multiplying by some fraction. Feet is upstairs. I want feet to go away, so I need to introduce feet downstairs. So this foot undoes this foot. What I do want out of my equation is yards, so I can introduce yards. And I do know the relationship between feet and yards. I know there's 3 feet for every 1 yard. Inspecting my units, miles went away with miles, feet went away with feet. I'm left with yards. Now I have this hour and this second kind of gumming up the gears a little bit. So I need to multiply by another fraction. Sorry, I'm running out of room here. So I'll multiply by one more fraction, or possibly more than one. So I have hours downstairs, so recognize I want yards out. I have yards sitting here. So what's left is to get the hours and the seconds to go away. Hours is downstairs, so I need to introduce hours upstairs. So this hour will be undone by this hour. At the same time, if I could introduce seconds downstairs, seconds downstairs will undo seconds upstairs. And this begs the question, what's the relationship between seconds and hours that makes this fraction equal to 1? That is to say, how many seconds are in an hour? Well, there's 60 seconds in each minute, and there's 60 minutes in each hour, so that means there's 3,600 seconds for every 1 hour. So let's go ahead and multiply this out. Recognize we are multiplying fractions with fractions with fractions with fractions with fractions. But wait, 22 is not a fraction. Well, yeah, it is. Just implicitly, there's a denominator of 1 sitting there. And I make note of that because from here, we need to multiply straight across. When we're multiplying fractions, we multiply straight across. We do not need to worry about the common denominator. So let's go ahead and multiply this out. Distance equals 23 times 22 times 5,280 times 1 times 1 units upstairs. Miles went away, seconds went away, feet went away, yards survived, which is good because that's what I want out for my distance. My downstairs, I have 1 times 1 times 1 times 3. 1 times 1 times 1 times 3 times, and then don't forget about this 3,600 seconds over here. Alright, now what is left is to multiply the numerator, multiply the denominator, and then do the division. So, let's see what we got going here. Try to get this in view for you. So we have 23 times 22 times 5280 times 1 times 1. Wow, 2671680. So 2671680. And then the unit of yards is also still floating around, still attached to the numerator. In the denominator position, I have 3 times 3,600. So, to get our final result, we'll take the 20, let's read this out. 2,671,680 divided by 10,800. which gives me 247.3777, repeating. Wow, so old Larry was cooking. Clearly not accurate within the real world, but nevertheless, it's a fun math problem. So what we're told here is we need to round the solution to the nearest tenth. So the nearest tenth would be the first decimal place. So we need to inspect our second decimal place and ask ourselves, is that big enough to round up my first decimal place? And the answer is yes. So our solution is 247.4 yards. .4 247.4. Moment of truth. Feels good. All right. So, the general strategy that we have going on here, we start with our general equation that governs the situation. From that general equation, insert what you are given. We were given a speed and we were given a time that brought us to this point. Now, once you have the speed inserted as a fraction and your time inserted, it's a matter of inspecting the units and asking yourself which units need to go away, which units need to stay, if any. We want yards out. There are no yards over here listed, so all three of these units need to go away. And in the process, we need to introduce the unit of yards. Miles was upstairs, so we needed to introduce a miles downstairs, so the two units undo each other. Hours was downstairs, so we introduced an hour upstairs to undo those units. Now keep in mind, when you're introducing these fractions, this introduction of these fractions is only valid when these fractions are equal to 1. So notice I did not introduce hours upstairs within this fraction because miles was downstairs. I can't relate miles and hours together to get them to equal 1. However, I can relate miles and feet together to equal 1. In a similar fashion, I can relate hours and seconds to get that fraction equal to 1. And when I say that fraction's equal to 1, really what I'm saying is that numerator is the same as the denominator. 5,280 feet is the same as 1 mile. 3,600 seconds is the same as 1 hour. Because the numerator and denominator are equivalent, that fraction in its essence is equal to 1. Keep track of your units. Once you have the no good units away and the good units appearing, it's a matter of multiplying straight across for your numerator, multiply straight across for your denominator, crunch the numbers for the numerator, crunch the numbers for the denominator, do the division, and then round. All right, so that takes care of this first homework question.